In the last few lessons, we have looked at how to add and subtract polynomials, multiply polynomials, and now we're going to look at dividing polynomials. And we're going to look at two different types. The first one is we're going to divide by a monomial. Remember, that's one term. That's the easiest type of division because we can rewrite it as separate fractions and just reduce each fraction. Using our laws of exponents and other knowledge that we already have, this is going to be really easy. So you can always separate a numerator but not a denominator. So since our denominator is one term, a monomial, I can rewrite this as negative 15x over negative 3, 3x to the fifth over negative 3, and negative 30 over negative 3. So we've separated the fractions. Now we're just going to reduce. So in this one, a negative over a negative is a positive 5x. 3 goes into 15 5 times. Here I can reduce that to negative 1, or just a negative x to the fifth. Then a negative over a negative is a positive. 3 goes into 30 10 times. You can leave your answer like that, or if you want, you could write it in standard form. Let's look at the next one. So again, we would separate those. I know that does take some time, but it's certainly worth it. Right now we're going to reduce each fraction. So 4 goes into 12 3 times, and 4 goes into 4 1 time. So this first fraction we have 1/3. Now look at the w's. We have more w's on top, so we're going to keep the w on top and subtract the exponents. Remember that rule? 5 minus 1 is 4. Then look at the z's. More z's on the bottom, so we keep that on the bottom and subtract 3 minus 2, which is 1. So you could write the 1 or not. Same thing for that. You could write that 1 or not. Now 9 and 12 are both divisible by 3, so that's going to leave us 3/4. Look at the w's. There's more w's on top, so we're going to leave it on top and then subtract. 4 minus 1 is 3. And what are going to happen to those z's? Well, you can keep the base and subtract the exponents, but you're going to get 0, and we know that's 1. We also know that z cubed goes into z cubed 1 time. The last fraction, let's see, 12 goes into 48 4 times, or 4 over 1. W divided by W is 1. And then on the z's, there's more z's on top, so we leave it on top, and 5 minus 3 is 2. I know that's an ugly way to write your answer, but you could leave it like that. That's fine with me. Let's look at this third one. Again, we want to separate the fractions. Oops, not 4, but what do we have? Y to the 4th. Okay, so on this first fraction, the 11's reduced to 1. I look at my x's. There's more on top, so I'm going to leave the x on top and subtract. Now, the y's, the only place they are is in the denominator, so I'm going to leave them there. On w, there's more on top, so subtract that, and you just get w to the first power. On the next fraction, we have a negative 22 divided by 11, so we could write a minus 2, or a negative 2 over 1, however you want to do that. The x's divide out, because they're the same. There's more y's on the bottom, so I'm going to leave it on the bottom and subtract. 3 minus 2 is 1, so that's just to the first power. What else cancels? The w's. They divide 1 time. On the next fraction, we have negative. There's an 11. That's it on the numbers. Let's see, x is also by itself, that's it. On the y's we have more on top, so we keep it on top and subtract. 4 minus 3 is 1. And the w's, there's more of them on the bottom, so we keep that on the bottom and again subtract, and that's to the first power. So these are really ugly answers, but that's how you do it. Again, you can only do that if you're dividing by a monomial when you only have one term. If you see any plus or minuses in the denominator, stop. You can't do this. That brings me to the next type of division. Long division. Now let's first of all review. How did we do long division back 4th, 5th grade? How did we do that? Depending on what country you came from and what state, it may look a little bit different, but in general, it looked usually something like that, not all the time. And you'd say 3 goes into not 152, you'd say, well, it goes into 15 5 times. You multiplied, you subtracted, those canceled, and then you brought down the next number. And you said, well, 3 can't go into 2 0 times, and so your remainder was 2. That's how we're going to approach long division here. Except usually we're not going to write the remainder with a big R. Later on, you should have learned to write your remainder over your divisor. And that's how we're going to do it. Now, let's look at number 4. We're going to take what we're dividing by. This goes into the numerator. And look at how everything is in descending order, standard form. You're not going to divide the whole thing. You're just going to look at those first 2 terms. And so what you're doing, either in your head or on scratch paper, you're dividing 2x squared by x. Well, we know how to do that, right? We kept the 2, reduced that, that's 2x. So we put that on top. Then we multiply 2x times x, 2x times negative 3. Now stop right there. Look and see what I did. I multiplied, and I wrote it right underneath the like terms. I'm going to get rid of those lines because that's going to get confusing here in a little bit. Okay, so I'm going to draw a line, and just like this, over here I had to subtract. So when we subtract in algebra, we add the opposite. So I'm going to change my signs. So draw this line and change your signs. Now add. This first term should always go to 0. If it doesn't, you messed up. Now let's see what we have here. Negative 13x plus 6x is negative 7x, and we're going to bring down the next term. Then we're going to repeat that process. We're just going to divide those first terms. We're going to divide negative 7x by x. We're still looking at that. And of course, that's negative 7. So we're going to put minus 7 on top, and we're going to multiply by what's in front. And we're going to draw the line and change the signs and add. And again, those should be equal but opposite. So when you add, you get 0. And here, positive 13 and negative 21 is negative 8. And then I stop. So I would have minus 8 on top of x minus 3. That should be my remainder. I know that's a little confusing, but it's not real hard. Let's do some more practice. Number 5, we're going to take the denominator, going to divide it into the numerator. Everything's in descending order. We're going to look at just those first terms, and that's what we're dividing. We're dividing 6x squared by 3x. So that's like dividing by a monomial, what we just practiced. So 3 goes into 6 2 times, That reduces 2x. So we put that on top. We multiply. We draw our line and change those signs. Draw that line and change those signs. Draw that line and change those signs. You won't forget that. Those add to 0. Now I have minus 9x. Bring down the next term and repeat the process. So again, we're looking at the first two terms. We're dividing negative 9x by positive 3x. And we get negative 3. So that goes up here. And we multiply. We have negative 9x and negative 15. Again, draw that line, change those signs. These are equal but opposite, so that's 0. And negative 10 plus 15 is 5. So we put our remainder on top of our divisor. So our final answer looks like this: 2x minus 3 plus 5 over 3x plus 5. That's what we would call our quotient. When you divide, you get a quotient. Now it's going to get a little harder because sometimes we have missing terms. Not everything is in standard form. It gets a little tricky. So we have to use placeholders. So do you see how we have 5x cubed, but it skips to 2x? So this is really 5x cubed plus 0x squared plus 2x minus 1. That is a placeholder. We don't have any x squared, so I want to hold its place because in long division everything needs to line up. So on number 6 we have x plus 4 divides into 3x squared, but we're skipping x. So I'm going to put in 0x minus 39. Now some students think that it's a little bit easier if you just put the 0. But you do need to understand that it is 0 x's. It's holding that spot for the x column. Alright, so we divide. We look at those first terms. And again, if you can do that part in your head, that's great. But we're dividing 3x squared by x. That goes up here. We multiply. Now do you see why we need to have that x column? It lines everything else up. So we draw that line, change those signs, and then we add. Those go to 0, and that is minus 12x. 0, which is nothing, minus 12x is a negative 12x. Then we bring down the next term. Repeat process. So we look at those first two terms, and we're dividing. Negative 12x divided by positive x is negative 12. So we multiply. We draw our line and change those signs. And we add. That goes to 0, and I believe that is positive 9. So we put our remainder over our divisor. That is our answer, otherwise known as a quotient. Let's look at that last problem. Do we need any placeholders? Well, we have x cubed, x squared, but oh, we don't have any x's. So we take our divisor, we take our numerator, put our placeholder, and set up the problem. Now again, you could have more than one placeholder. You might not have any x squares or x's. Okay? You can have more than one. It's not always just for x. Right, so we're going to look at those first two, and maybe at this point you don't need to write it out. Maybe you can just divide. But this is again what we're dividing. We put that up there, and we multiply times what's in front. Draw our line, change those signs, and add. Again, those should be equal but opposite, so that's 0. And we bring down the next term, even though it's still 0. That's okay. Then we divide, and we look at 18x squared divided by 3x. And how do we reduce that? You just get x. So it's a positive 6x. If we would have had negative, you put a negative sign up there. We're going to multiply by what's in front. Draw that line and change those signs. Equal but opposite. Bring down the last term and keep going. This is a little bit longer. So again, we divide those two. 24x divided by 3x is positive 8. And of course we're multiplying by what's in front. Draw that line, change those signs, don't get lazy now. And we have a negative 6. So I'm just going to say minus 6 because of the negative over 3x minus 4. So that would be my quotient without all those lines, of course. But we would have x squared plus 6x plus 8 minus 6 divided by 3x minus 4. Now I know that was kind of fast. Stop, rewind, go through the examples one more time, check to see if everything's in descending order, and see if you need placeholders.